80 by 60 feet. A large path of uniform width is to be added along the shorter sides. So let me draw this out. Okay. 80 by 60. I'm going to put these on the inside. Because I'm going to be extending this. So 80 by 60. A large path is going to be added along the shorter sides. So large path along the shorter sides. So I'm going to add a path or to the shorter sides and one longer side of the problem. Dang. That's stressful. So I'm adding a path to the shorter side and one longer side, but not both. So they're wanting it to be like this. I'm adding a path. Now, how long is that path? I don't know. Y'all see? Pay attention. I almost missed it. Do y'all see why I'm not doing both longer sides? Because they said just one longer sides and the two shorter sides. Now, this width that we don't know that they're trying to add, what is that going to be called if I don't know it? This unknown value. X, you can call it W, just a variable we don't know. So I call it X. Okay, you can just call it a variable you don't know. But on the example here, they added it to the entire garden. Here, they're just doing it one longer side, not both. And they're wanting to double the area. They're wanting to double the area. So let's talk through this. We know the area of this, length times width. Okay. Now, what is the current area? The current area would be what? 80 by 60, right? 80 times 60. This is a stressful problem. 4,800 feet squared. What would the new area have to be? They weren't to double it. So what would the new area have to be? 9,600. So this is our new area. Now I need to know the length and the width. So this problem's a little stressful. Here. So they want the new area to be 9,600 feet. So now we know the area, we want it to be 9,600 feet. We need to know the length and the width. And I don't know what's length and what's width. Just one dimension. One's one dimension, one's the other dimension. So we need to know an expression for this dimension and expression for this dimension here. Okay? Let's talk about this dimension. This gets a little stressful. What's composed in this dimension? We have X, 80, and X. What do we do with those to find the lengths here? No, I'm just kidding. Sorry about that. What do I do to find this whole dimension? That's X, 80, and X. What do I do with them to find? Like if it was 5, 10, and 5, what would I do what would the total length be? Add them up. So what am I going to do with X, 80, and X? Add them together. Good job. What's X plus 80 plus X? 80 plus 2X. Dang, you're doing so good on this. This is hard. It's a stressful problem. Too bad that I didn't put this one on the test. What about this dimension? What would this one be? It's 60 to here, then plus what? 60 plus X. Now, if you added to both, it'd be 60 plus 2X, but we just add the one side longer one. I know this is very stressful. Okay. Don't break up with college algebra after this one. Now, the area, 9,600, equals this times this. So 60 plus X times 80 plus 2X. Promise you the last one won't be this bad. What am I have to do with this junk here? Multiply it. So I'm going to have to multiply here. I told you this one would be stressful. We were doing so good. Just mowing through these. And then I had to throw this one on you. It's 80x plus 2x squared. 9,600 equals 2x squared plus 200x plus 4,800. Pause here. How are we going to solve this? What do we need to do? Make it equal 0, right? Quadratic equation. 4,800 minus, that's going to be, there you go. They all have a factor of, okay? I think this will factor. We could factor out 2, couldn't we? I want to try to factor this because I don't want to. Peyton's like, when's it going to stop? It's never going to stop. Never ends. What multiplies negative 2400 and adds to 100? 2400 divided by 40. Oh, I got luck. Well, no, that's not going to work because one of them has to be negative, so that's not going to work. What about by 20? There you go. I need a plus 120 and then minus 20. So set each of these equal to 0. This 2 just goes away. So subtract 120, subtract 120. X equals negative 120. X equals 20. I got 2 answers. X equals negative 120 and X equals 20. What do y'all know about that? I bet Cole's got me on this one. We're going to throw out the negative answer. It's an extraneous solution. We'll keep the 20. I don't even know if that answers the question because they don't know the area. How wide should the path be? Is the width the large path with uniform width to be added? The shorter sides and one longer sides. So you're adding 20. So this is 20. Oh, so that makes them each 100, doesn't it? Right? Wouldn't this make... Because this side, wouldn't this dimension be... Wait, no, it'd be 1... Wait. This dimension would be 20 plus 80. That'd be 120, and the other one would be 80. It'd be 120 by 80. Which one's the width and the length, though? Well, how wide should the path be? That's just X. That's just 20 then. I'm sorry. It's just how wide is this path that they add to it. So it's